So, have you ever written a code without understanding why you're doing this? Raise your hand up. I've done it multiple times. Probably you did too, as well. Yeah, it happens all the time. So basically, we are pretty good at understanding what we are building, but usually we don't understand why. What are the business decisions behind it, right? So that's quite important, as you will see in a moment. Another question, would you like to have a real impact on business decisions? You as a developer, as an engineer? I would. Yeah. That's nice to actually feel you're doing something, not just writing code, right? That you have a real impact on what's being built. So in just under 45 minutes, I'm going to show you how you can solve these problems by using domain experiments, which is my own custom framework built for the Becoming a Technical Business Partner series of presentations and trainings. Okay, so maybe let's start with some story. Let's imagine a project of really great developers that used domain-driven design, test-driven development, clean code, all the best practices. Generally, masters of technology, right? So it seemed they need to succeed. There was no other option. But at the same time, they were not something I call technical business partners. They were not interested in business decisions. They were not interested in why they are building stuff. They were not interested in sharing the domain knowledge. So what was the result? What do you think of building such a project by this team? Was it a success? No, rather not. It was a total failure. Yeah, they thought they are building something extremely good, amazing. Yeah, but it worked as usual. Why? Do you have any ideas why? Yeah. Yeah. And because we don't really know why, yeah, and we don't know what we are building up front. That's this moment we need to explore it. Yeah. So, building software is in fact all about discovery and learning. Learning not only technical stuff, not only architectural stuff, but also the domains things, understanding your clients, understanding your unique value proposition, understanding your unique selling point. Yeah? That's all about understanding all of the important parts of why, not only what. This particular team failed because they were simply learning too slow. They haven't realized that it's single most critical part of building software, actually, learning. So, what can we do about it? The answer is rather obvious. We need to learn faster. Yeah. But what's the best way to learn? What do you think? How do you learn best? By experimenting? By trying? Maybe someone likes to learn the other way. There is a Kolb cycle of learning. Different people start from different parts of this cycle. Sometimes people prefer to first understand then try. Sometimes they prefer first to try and then to understand. But from my experience, we developers usually learn best by trying something. Yeah? By getting our hands dirty on some very specific code and then try to understand the bigger picture. So by practice, in my opinion, by experimenting. Yeah? And basically all practical science is all about experimenting, about trying stuff, right? Verifying some hypothesis, just like Jakub said in the previous presentation. So the question is, can we run and how we can run these experiments in code? So there is such a thing called a prototype. Yeah? I'm sure you built multiple prototypes in your life, in your career. That's quite obvious. Yeah, we love building prototypes, especially when doing startups. Yeah? we are doing one prototype and then just, well, it crashed. So what do we need to do? We need to rewrite it. Yeah? Why it crashed? Usually not only because of technical reasons, you know. Yeah? One of the things it crashed is that because we misunderstood each other. Yeah? We haven't realized about the very important concepts. So prototypes might be a great idea, but there's one thing with prototype. They are costly to build because you're building, in fact, entire application. All the layers, application, infrastructure, you need to think about some scaling. Maybe you, from day one, start, oh yeah, we will do microservices with Kafka, yeah? Because it will suit us best. But it's just an assumption. It's not based on any proven hypothesis. So what I propose is to run experiments directly on the domain code, on domain model of what we are building. Okay, so maybe I'll tell you how you can run experiments in greenfield projects. Later on, after presentation, we can talk how you can run it in legacy projects if you want to. But let's focus on this, okay? So what you see here is, maybe I'll try to point it out if this works. Yeah, it doesn't work. Okay. So how do you run actually this experiment? So you start, I'll write it loud since I can point it. You start with some way of knowledge crunching. Yeah? You can use multiple ways. For instance, big picture, brainstorming sessions. You can just talk. You can maybe share some meaningful documents. It's up to you. Yeah? You need to start to knowledge crunching. Personally, I prefer to start with product vision board. That's something that tells us what we are building, why we are building, what are our clients, something similar to business model canvas if you're up to startups. So anyway, you start with something. You start crunching knowledge. Then what you do, you try to extract key processes. You know, my preferred way to actually start finding these key processes is to ask my clients, okay, so you got 4 weeks to get on market or you die. What do you build? What's the most critical, important part of your business? You can also use wording maps for this, for instance, to evaluate where on the level of evolution is your current solution. And then based on it, you may say, okay, we will either buy it or we will build it. Huh? Or maybe we will outsource it. So it depends. Okay. So after extracting these processes, you try to split them into examples. That's the part which uses example mapping. Simple stuff that simply takes a process and says, okay, the one where something went good, the one where something failed, the one where form was filled, you know what I mean. What you do next is you take this example and you start something I call code storming. Yeah? And again, Jakub mentioned mob review, and that's like a mob programming, but applied only on the domain level. I'm generally against mob programming, but that's the moment where it actually works well, because we are exploring stuff. So what we do, we take this example and express it as a test. We write it. Then we create the initial model to support this one test. Usually this first test would be meaningless. It would be just something, okay, we can create something or we can make an order. You know, you get what I mean. But it will start building our ubiquitous language in the initial model. What do we do next? We verify and challenge the model. We try to actually break it. Yeah? Then ask others to verify and challenge the model together with us. We're working with 3-4 people on this. And then we refine the model. Afterwards, we take another example and create yet another model. And we keep looping over this. Yeah? So it's all based on the same methodology as test-driven development. Yeah, test-driven development is not methodology, but the way of thinking, actually. Okay, so what happens next is we ask ourselves, okay, is this model the best one we can do at this point? Is it our best decision? Is model accepted? If model is accepted, we create ADR, architecture decision record, but applied to the design model. So we say, okay, given the context, given our needs, we decided to, for instance, use aggregates with such and such method because of. Or maybe we decided to not use aggregates at all, and we might still decide, okay, this is a simple CRUD module, so we will just write the transaction script. And then we say, okay, because of this, it might be harder, for instance, to refactor it later, but we might get straight to the point because we assume it will be simple. Or the other way, right? So anyway, even if model is not accepted, if we say, okay, well, it didn't work well, we can't say if it suits our needs. We didn't find anything yet. We have doubts about it. What we do, we still have a lot of questions to ask to our domain experts. Yeah, we found out with some meaningful facts we need to establish. We need to decide how things relate to each other. So what we do, we take these questions and we go back to knowledge crunching. And we ask meaningful questions directly to the domain experts. And everything repeats. So that's how I perform domain experiments in greenfield projects. To make it work, feedback loop must be extremely short. So at the beginning of the project, you can't have contact with domain experts like once a month, yeah, once 2 weeks. It wouldn't work well. You need to be in constant feedback loop in the very early weeks of the development. So feedback loop must be short. At the same time, if you are working in an environment that is unwilling to learn, yeah, or admit that there are some problems with the existing solutions, admit that they made mistakes, well, in such case, you're basically doomed. Yeah? You can't do nothing about it because your environment wouldn't allow you to actually perform these experiments. So you need good people around it, not necessarily technical way of thinking, but people who care of what they are building and why they are building this. So in such case, don't even try to do other experiments. Will only waste your time. You can apply DDD Lite, you can apply some technical patterns, but that's all. Don't think about actually understanding what's being built. This way, at least. So previously I mentioned about the example method, and as we established before, the best way to learn is by examples. By examples, we really understand what we need, and there are a lot of disambiguities that might appear that are simply solved by expressing stuff just like you would express it to a child. So now, when you combine the example mapping with test-driven development, you get something awesome. And I would like to show you how you can actually start with this. We'll go through a very simple demo of performing initial rounds of experiments to show you how it can actually work. So I prepared a repository for you. You can find it on my GitHub if you would like to check it out later. But maybe let's start. Let's start with the definition of what we are building and why we are building this. So usually we have something like some simple vision document. Yeah? Someone comes to the table and says, oh yeah, I want to build this and this because of, yeah. So let's imagine that there is a project called Crowdsourcery. Crowdsourcery is a platform supporting passive investments. Something like Finex maybe, or Estate Guru if you're into investing, that kind of things. You basically transfer money, you set some algorithms, and the platform invests for you into the new opportunities. So our main value proposition is that investors usually have some free money to invest to, but they don't have time to manually invest into stuff, right? So that's why we decided to do that. That's our main value proposition. So initial requirements we might have for our vision document might be something like this, very vague, like any borrower can start the fundraising to finance her project. Investors can invest into assets. Investors receive returns based on the asset they invested in. And at the same time, sorry for this, investors receive returns based on the asset they invested in, and borrowers receive funds to finance their project based on some schedule. So these are the 4 initial requirements, and we will focus on the first one only, just to show you how it works. Okay, so let's switch back to our mirror board. So you remember in the code storming framework, in the domain experiments framework, we started with knowledge crunching here. So what I do first, we might start with some big picture format, for instance. Yeah. So let's imagine we decided to, okay, so let's say what's happening here. Important facts. Project funded, investment made, project defaulted, project repaid, schedule accepted, funds received, deposit made, funds withdrawn, investor registered, all that kind of stuff that are coming from different domains, different contexts, doing different stuff, but are some meaningful facts in what we are building. Yeah. So what we do next, we try to find processes. There are multiple ways to find processes, but this presentation is not about finding processes. If you're interested, we can have a talk later. Generally, I prefer using pivotal events for this. But let's imagine we already found some processes. There are two key processes we see here. The first one is fundraising, and the second one is investing. So the fundraising is something like that. Borrower registered, then schedule is accepted, then project is started, and then one of two things can happen. Project is either cancelled or funds is received, and if enough funds is received over time, then finally the project is funded. Yeah? Similar in the investing way. Yeah? Fundraising is from the perspective of the fundraiser, of the borrower, and investing is from the perspective of the investor. So what happens? Investor registered, deposit made, investment made, project funded, interest paid, project repaid afterwards, funds can be withdrawn, or payments not received on time, and then the project is defaulted. Defaulted, you can think of cancelled, something like that. Okay. So these are two key processes here. And just by looking at these processes, we can find some use cases inside it. One of the first use cases here we might start with is actually starting a project. Yeah, we want to fundraise something. Before we fundraise something, we need to start this project somehow. Yeah, maybe the better name would be fundraising here. Yeah, but let's leave it like this. It's not perfect. So you see there is some format here. The blue ones are rules. Usually I don't start with rules. Rules emerge later on. I usually start with the green ones. And the green ones are examples. And these examples are actually read in the third party way. I mean something like the one where adult borrower starts a project. The one where borrower without criminal records starts a project. Yeah? The one where it's okay when value of the fundraising is less than $10,000. So it's not. It doesn't need to be very specific. It's not like in BDD, given, when, then, with all the specifications. These are just some cases we want to cover. Okay, and what we do now, we take this example and make it a bit more specific by going directly to the code. You might start with design level event storming sessions, but there is one problem with design level event storming session. It's still whiteboardy. It's still paper. It can accept anything. Yeah, and it happened multiple times to me that we modeled something and we thought, yeah, that's awesome. But when we started to actually implement this model, yeah, there were a lot of cracks inside it that we found out only after starting implementing this. So, you know, at the design level at the same time, usually there are no domain experts. Domain experts are with you up to the process level of the event storming because they are interested in these things, but they are not interested in design. So what I propose is to jump immediately to the code and start writing it. And let's experiment, let's have some fun. So I'll start with virtually nothing. I got a simple bootstrapped Spring Boot application without anything. Everything is completely empty. So what I do now, I create a class. It might be called something like example mapping session. Yeah. You see, I started with some tests. Yeah. I'm using here a Jupyter, so I might give it a good name. So examples taken from our mirror session. let's experiment a bit. Okay, so what do we do now? We take this case, like, you see, adult borrower start a project. Awesome. Adult borrower starts a project. Yeah, so I just copy pasted it here, basically, and you see we have nothing, not even a single class now. Yeah, so what I do, I actually start building the ubiquitous language and the model supporting it. Yeah, so what I do, I say I want to have some kind of a borrower. Yeah, okay. Okay, then what? This borrower wants to start a project. There needs something that actually allows you to start a project. Yeah, there needs to be some system. And now, according to Alberto Brandolini, we don't need to name things, right? We don't need to even search for any kind of aggregates yet. We are just exploring stuff. So what I do now is some system that allows you to start your fundraising. Yeah? Okay, it might be AA, BB, blah, blah, whatever. It doesn't mean at this point. So what I do, I create it. Go back. Yeah? Some system. Okay? Awesome. And what we do now is the system needs to actually allow to start fundraising, right? So what do we do? Start fundraising. Yeah? Okay. And now, actually, we say that there is an adult borrower that starts the project, so we forget about one thing. What we should have is that we should have start fundraising by, yeah? And here we add a borrower. Okay, so now we want to express that something actually happened. There are multiple ways we can do that. You can use states if you prefer to. What I prefer is to actually build things around domain events, just like on our whiteboarding session. So what I do, I usually do something like that. There is some domain events being returned, not published yet. Yeah, you can publish them whenever you want to. It's being returned. It's just logic. So what I do now, I again create these domain events, right? So, and I make this start fundraising by method to return it. Okay. So we got some events, and afterwards we say something like events here happen at least once event of type happened, something like that. Some utility method here, and we say that what kind of event? I don't know. Project fundraising started. This event is taken directly from the event from our Storming session. Okay, and we create it again. Yeah, this might be a domain event. We can say it's a marker interface here. Okay, and now we add an argument to the events, and we say that it actually returned that event happened. That it returns a boolean. Yeah, something like that. So let's make it a bit simpler. Assertions, assert that is true, something like that. Okay, and you see, the reason why I showed you it during the live coding session here is just to show that we start with nothing. Yeah, there are multiple ways you need to fill in. There are gaps. There are not rules yet. Yeah, it's just something like there is an other way that can start a project. So there is some system that can actually allow you to do that. Yeah, but there are no rules yet at this point. So the reason why we started with this is to actually start building the foundations of the ubiquitous language. That's our very initial model. Very, very simple one. And we will keep refactoring it over time. So now I'll go through the history of commits, because we are having pretty limited time, and show you how the evolution might actually look like. Okay. So first of all, let's reset everything. Awesome. And let's get to the first step here. So that's our first step. In a bit more polished way, given other borrower when the borrower wants to start a project, and project is started successfully. So it looks quite similar to what we created so far. That's the first step actually. Now let's go to another one. And in the another one, we actually start finding some rules. So we go back here and we say, okay, so it's adult borrower, right? If it's adult borrower, probably there are some rules telling me, okay, you don't want to allow to borrowers younger than 18 years old, for instance, to start a project. So that was the previous case you see here. And another case is given borrower who is 17 years old when borrower wants to start a project and project is not started. Yeah. So we again invoke the command here, but we want to start a project, and we say that no events occurred in this case. And this is actually the first moment where first if appears in the production code. Yeah. Only after that, only after understanding why and what. Yeah. So let's go to another step. Awesome. So there can be some simpler factorings happening over the iterations. That's natural. So at this point, we decided to tell, okay, so what about 17, 16, 8, 4, and 2 years old? So we decided to use a technical step of refactoring into parameterized tests. So that was simple, right? Okay. Let's go later on. And I haven't showed it to you, but the previous implementation of the borrower was extremely naive. And we simply passed something called age. Eh? I haven't showed you, but it used to be like that. Yeah, that's completely dumb. We don't want to update age every day of every users. But we can allow to actually have dumped iterations of the code. So in this step, what we do is we naturally pass the birth date here. Very, very small step. But step 4 actually is quite interesting here, because that's the first breakthrough in the model. Because you see, let's start thinking about this. Yeah, we are having an investment platform. We are having some borrowers, some adult borrowers, some adolescent borrowers, and we allow both of them to actually start it by protecting it by rules. It doesn't click the right way. I believe so. I mean, should we ever allow borrowers who are not adult to register into our system? We are operating on money, on investments. Probably doesn't make sense when we start thinking about it. So you see, we might get to the breakthrough also by working on code. So yeah, we start thinking, hey man, it doesn't make sense. So what we can do about it? We can have another case, and this time this case is special because we found out this case by implementing the model. So what we see now is another case, new borrower registers. And we say only adult borrowers can register their accounts, yeah, and express it here into the tests. So the first breakthrough actually allowed it to understand that we don't need to have this case here at all in starting a project. Instead, there is a new use case, new borrower registers, and then we might have some rules. And this might be a completely different system than what we've been building previously. So just by looking at code, we might have some breakthroughs, we might have some questions, and we might start actually questioning our assumptions. It's intentionally kept simple for the needs of this presentation, naturally. So what happens next, if we go step by step by step, is that actually, maybe let's go one more step later on. Change registration here, okay. And let's go back to the case of criminal record. again, yeah, we can start with stuff like starting it and telling you we check the criminal record, but again, we don't want to probably have criminals in our system at all, right? So we should move it at the stage of actually registering them, checking them. So what happens here is that we have new bureau registers, still the same case, yeah, but new example, person with criminal record cannot register her account, yeah, and in such case, we even created a thing called borrower registry, something that allows us to register borrowers. Maybe it's not the best way, maybe we should ask, but it's our assumption at this stage. And we say, okay, it allows us to register based on some register form. Yeah, register form here, registration form. And then based on it, we got some special, service that checks whether performs user due diligence and checks whether she has criminal records. So these are again things pushed at the moment of registration, but you see there are some things happening on the code, like some policy checking this, some due diligence facts, some borrower registry, yeah. So things actually are built from the button to the app, and we are discovering just by iterating on the model. Okay, so let's take a look. Let's take a look here, because again we decided here to move the criminal from this to again to checking it to the new bureau registers case using the bureau register. That's our new definition found out. Yeah. So after iterating this stuff, we see that actually what is really verified, that needs to be verified, is some money related stuff. Yeah. So okay, when it's less than $10,000, for instance. Okay, so we have these cases here. Yeah, at starting, we are still at starting the project here. Starting a project. We are in this use case, and our examples now check rules regarding, for instance, given project proposal of 9,000 total value. When borrower wants to start a project based on this proposal, then project is started successfully immediately, yeah, because it's less than 10,000. Okay, but it might happen that given the project proposal of $10,000, when borrower wants to start a project based on this proposal, then project needs to be verified first. So it's not rejected; it needs to be verified somehow manually. Yeah, and we again express it just by expressing it over the events produced by our comment handlers. At this point, we don't care whether there are some objects, aggregates, or that kind of stuff. It can be functions. We don't care about it. Yeah, it's just something that accepts the command and allows us to produce events. So there are questions we might have. Yeah. Okay. So do we ever reject immediately stuff? Yeah. But because you see, okay, so it's accepted for proposal. There was such an event during our storming session. So maybe there are some other rules, yeah? And we start questioning things. We start asking the right questions. Okay, so my dear domain expert, what do you say? Should we reject it or not? Do we ever reject it immediately? Or we always at least give a chance, yeah? And we start iterating over it. Okay, so basically there are more rules here being written in the code, but I believe you understand the concept. You see how it actually is being performed here. So instead of going deeper into the code, let's take a look at our board after some iterations, yeah? So we found out that starting a project actually verifies only money at this point, and then the project can be started, or it needs to be verified manually when it's greater or equal to $10,000. And in such case, project proposal is accepted for verification. And now we might have some questions like how verification works, how we are actually doing this, yeah? How we are conducting, what are the rules behind it, yeah? There are also some new definitions. over the course of our very, very initial experiments, like project proposal supervisor, someone that checks if project proposal is okay or not. So there are multiple concepts. And what's fantastic is that we haven't touched any infrastructure code yet. Yeah? We just iterated on simple domain model. So we first verify some hypotheses, we check them, we experiment on them, we move very, very fast. And after a day of running such experiments, we have tons of questions, doubts, and questions we might have, meaningful questions we might have for our domain experts. And we go back to them, and we go back to them. And you know what? We discover very important facts in as few time as 2 weeks, 3 weeks, 4 weeks of actually working on this. Sometimes more than working for 6 months on a project that's being deployed on some AWS infrastructure, Kafka, and that kind of stuff, and because using microservice, because we only assume it, yeah, when giving an offer to our clients. And then we find out that we simply misunderstood each other, and we don't even allow criminals in our system. Okay. So there's one more thing. Have you ever seen, played, or heard about Gloomhaven? That's a very popular board game, actually #1 on Board Game Geek. So if someone likes board games, she probably knows it. And it's a fantastic game where you are building your own characters. It's like an adventure game, a bit of RPG, tactical game. You go through a campaign. It's completely awesome. I highly recommend this. And like with all of complicated games, or maybe complex is the better word, like a lot of complex games, there are rule books. And there are multiple rule books. One rule book is not so huge, something like that. I remember my old days in D&D when I memorized all the books of rules, something like that. Thousands of pages in my head. It's not the case. It's also not like Warhammer, if you ever played it. But still, there are some rules. And you see, these rules are very well explained. It's actually one of the best rule books I ever read. And then there is a monster movement rules. And you see, by monster movement, I mean we are playing against the game here. It's a mostly cooperative game. Not necessarily, but mostly. And here are the rules, algorithms, describing how monsters move. And you need to take a look at the state of the board. And according to these rules, you say, okay, the monster will focus this player and it will attack it and try to move it the shortest way, for instance, or maybe the other way, according to some rules. And when you have some experience in reading rule books, playing board games, RPGs, that's when you read it, you say, yeah, that's obvious. It's absolutely clear. I understand it. And then there are things like Monster AI quiz, the Gloomhaven rules quiz, rule quiz, or even a series of tens of videos how monsters move on YouTube. I mean, most of players actually misunderstood the rules in the rulebook and are playing it wrong. And even if you played tens of games in Gloomhaven, you might fail at this rule quiz. And then a computer game implementation of Gloomhaven appeared. And now everything is clear. Yeah? That's the reference implementation of these rules. There is no way to misunderstand rules at this point. There needs to be some fixed way of actually interpreting them, right? So I'm showing you this because it's similar to the case of design level storming sessions on whiteboarding, where you say, okay, the model is clear, yeah, we understand everything. Everything is completely fine. We did a great job. And then when you go to the implementation, you say, oh my, but what happens when someone tries to register here and at the same time is VIP, but has a criminal record? Probably we shouldn't allow them, but maybe under the table we want to allow them to do something. Yeah, we don't necessarily need to run a fair business. I don't know. Yeah, there are rules, doubts, what might happen, and you actually codify these things only after implementing them. Only after implementing them, you're sure that these rules work the way. So, vision boards, whiteboarding sessions are a source of inspiration for us. Computer games implementations are a source of truth. And you know, in domain-driven design, it's all about minimizing the gap between the source of inspiration and the source of truth. I hope you enjoyed it. I'm Mike Wojtyna, MichaŁ Wojtyna in Polish. I prefer to use Mike because a lot of my clients used to call me MichaŁ, and I hated it. So if you enjoyed that, I have a thing called howtobe.pro. It's my training program. You can join it. Take a look at this. There are a lot of things regarding domain experiments, modeling, domain-driven design, architecture. If you enjoy it, I welcome you to join us. You can contact me at any time through mail or just connect on LinkedIn, and hope to stay in touch and that you enjoyed this presentation. I believe we have some time for questions and answers now.